The preferred settings for viewing topographical maps using the Scout software is accessed by placing the cursor on a curvature map and right-clicking. This brings up a drop-down menu which you should choose Options from. Within the option menu, you should set Simulated K, Show Pupil, Show 3 Zone, Axis plus Grid, Show Eye References. Then for Process, have both the curvature and the photo process options checked. This enables you to quickly view and measure the overall corneal diameter. For instance, on this eye, because this grid is 12 millimeters across, each mark representing 1 millimeter, we can quickly see that this cornea is about 11.4 millimeters in diameter. The 3 zone are the 3 rings that are shown centrally. The pupil is the center ring that is usually offset slightly. The central ring is 3 millimeters across, the middle ring is 5 millimeters across, and the outer ring is 7 millimeters across. By using these 3 rings, you can quickly gauge the size of this pupil and tell that this pupil is a little bit more than 3 millimeters. For multifocal or ortho-K purposes, it's best to have a pupil measurement close to the 3 millimeter and less than the 5 millimeter in size. When designing ortho-K lenses, using the overall corneal diameter is helpful because it's best to use an overall lens diameter about 0.2 less than the overall corneal diameter. So in this instance, an ortho-K lens would best be about 11 to 11.2 millimeters in overall diameter. Usually we have more than one topographical map obtained from a patient's eye. In this case, we have 4 maps of the same left eye, and we're presented with the decision as to which map to use. The first thing we look for is interference by the upper lid or lower lid. As you can see, the first map has quite a bit of distortion in the upper portion of the map caused by the upper eyelid. So we'll eliminate this map and not use it. Then when we compare the other 3 maps, we notice the central area has a steep area in this map, whereas the other 2 are more similar. So we'll eliminate this map because of this anomalous steep area centrally. Now we're left with 2 maps, and once again we look for overall coverage. In this map it looks more consistent and smoother and has a broader area of regularity, whereas in this map we have a little bit more disruption both in the lower portion and the upper portion of the map. So we'll eliminate this map and decide to use the last map taken as our map that we'll design our contact lens with. Once we've chosen the map we want to use, we can use some of the manual editing features of the Scout software to eliminate some of the distortion in the periphery of our selected map. We will use the eraser function. With the eraser function, as we hold the cursor over a portion of the map in the process editing screen and hold the left mouse button down, it will erase the data in that area. As you can see, we have some irregular areas inferiorly, so I will erase the lower rings on this map in that area. Once the rings are erased, they're turned purple or pink so that you can tell that they've been removed from the data. There's also a distorted area superiorly being affected by the upper lid. Once we've eliminated our distorted areas, we'll click OK here and choose Yes. And as you can see, our curvature map is updated to show us the effect of our editing. If we have a few other areas that we want to eliminate, we can go back and edit a little bit more. Clicking OK and again choosing Yes to get our preferred map. After having edited out the distorted areas, we will extrapolate this map. After clicking the Extrapolate button, click the Parameters button and place the cursor on the screen in about this area, here, and finally at this location on a broad area out on the sclera to extrapolate our data.